Welcome back, everyone. We're going to do a quick video tonight on combined gas law. I know you've already taken notes on combined gas law, so the purpose of this video is really just to set up a few problems and let you see me work through it. So before we get going here, let me just remind you that when we deal with gas laws, we're always dealing with pressure, volume, temperature, and we've looked at Boyle's, Gay-Lussac, Charles's law, and how those relationships exist. And we're going to take these three now, and we're going to vary each of these three instead of just two at a time. So the only thing that's going to stay constant here is the number of moles. So N is constant. Again, that's the number of moles. So the combined gas law is just a combination of all those gas laws that we've already written. So if we started, for example, with Boyle's, P1V1 equals P2V2. All we have to do is add Charles and Gay-Lussac into that, and we know that if we did Charles' law, it would be V over T, and so we can just put that T's there just like you see, and then if we cover up the V's, you can see that we have the Gay-Lussac law as well. So we combine everything. Again, the only condition for combined gas law is that the number of moles has to be held constant. All right, so let's do a couple problems here real quick. This paper here that you see, you will get posted to Google Classroom or in class, and then you can print it out and work along with me if you want. And the key will also be attached to this as well, so you can check your work for some extra practice before you do your main homework. All right, so number one, initially have a gas at a pressure of 12 atmospheres, so that sounds like a P1. And then a volume of 23 liters, that sounds like a V1, and a temperature of 200, that's T1. And we're going to raise the pressure. Well, before I go into all that part, let's go ahead and set this up. We have 12 atmospheres and 23 liters, and we're going to put that all over 200 Kelvin. All right, so that's my initial set of conditions. And now the rest of the problem statement, and then I raise the pressure to 14, so that's going to be my P2, and increase the temperature to 300. What is the new volume? So there's your question, and you can make that your variable of choice, or you can use X if that's kind of the way you do it. Now, for some students, the algebra is the trickiest part of this. We can go ahead and simplify both sides if you like, but for a lot of you, I'm going to go ahead and recommend that you do some algebra movement around before you start simplifying. So what I mean by that is, let's get V2 by itself. So I'm going to multiply both sides by 300 Kelvin. So that gets rid of the 300 Kelvin. And then I'm going to divide both sides by 14 atmospheres on both sides. And so I've moved the numbers around before I've ever have to do any simplifying or use the calculator at all. And now that I've done that, I'm ready to just plug and chug. Before I do, let me just point out that we're still doing proportions here, so your units have to match. So I'm looking here, my temperatures both are in kelvins, that's good. Pressure, atmospheres, both of them, and they cancel out. And that's going to leave me with just the L here, which is exactly what I want for the volume. All right, number time. 300 times 12 times 23, and that gives me a numerator. I'm going to go ahead and divide by the denominator by 14, and then divide by 200. And that's going to give me, rounding to 1 sig fig, gives me 30 liters for the volume. So this is very similar to the Boyle's, Charles, Gay-Lussac laws that you did in last week's assignment. All right, for expediency here, we're going to skip number 2. It's a very similar problem to number 1, so you're not going to learn a lot from that one. So let's go on down to number 3 here, because there's something I want to remind you of. In this problem, it says a gas has a volume of 28 liters, a temperature of 45 Celsius, and an unknown pressure. So maybe that's my P1 there, unknown. Its volume is increased to 34. Its temperature is decreased to 35, again in Celsius. If I measure the pressure after this change, that's my P2, what is the original pressure of the gas? So we're going to set this up. Again, we don't know what P1 is. That's our variable. For this problem, we have 28 liters at the beginning. And here's where I want to remind you of something. The temperature given was 45 Celsius. You cannot plug in a Celsius temperature. You should never plug in a Celsius temperature into a gas law problem. So let's come over here to the side before we get going here, and let's convert that Celsius temperature into a Kelvin by adding 273 to it. So that's going to give me 318 Kelvin as my first temperature. 318 K. Never plug in Celsius. Alright, so our P2 here is 2 atmospheres. The volume has changed to 34 liters. And once more, we've got to change that temperature. So let's come back over here. 35 plus 273 gives me 308 Kelvin. So this is 308. All right. So for the benefit of those of you who don't like algebra very much, I'm going to go ahead and move my numbers around before using the calculator. Let's multiply both sides by 318 Kelvin. Okay, that cancels out over there. Let's go ahead and divide both sides by 28 liters. Okay, that gives me P1 all by itself, which is exactly what I wanted. Excuse me. Now, let's check our units out over here. The liters will cancel. If I had put my kelvins in there appropriately, they would have canceled. And then that leaves me with atmosphere. So now it's back to the calculator. 2 atmospheres times 34 times 318 divided by 308 divided by 28. So that gives me 2.5 atmospheres. All right, well that's it. That's combined gas law. So take a look at this, practice a few of them, check it with a key, and ask your teacher for help if you need some further clarification. But this is the combined gas law.